Hello, MTV! LAB11, diffraction, your boy Ian. Using the equations, calculating the edge of the Fraunhofer region, we found that for each slit, it was 0.16 meters, or 16 centimeters.
For part A of the lab, what we were doing is we were observing how different slits of different widths would change depending on when they were placed on the aperture. And by moving this camera back and forth, seeing how the slits would change depending on how close or far the camera was.
So analyzing the different shapes in the Fresnel region, the single slits started stretching the image of the slit until it was just a straight line of Fourier transform function. The double slits created interference patterns overlaid on the single slit Fourier transform pattern. Different slit sizes made the oscillations of the main sinc function much more defined and with slower oscillations. And using the complex shapes, triangle created a very complex function where it functions spread out from 3 different points. The rectangle and square mimicked that of a single slit, and the circle created an airy disk when approaching the Fraunhofer region.
For part B of the lab, what we did is we measured the diffraction pattern of the rectangular single slit by looking at it at the Fraunhofer region, which is this area right here, where it starts to create like 2 sinusoids. And then using MATLAB, we were able to make these plots and compare the sombrero and cinch functions of each and determine which one fit best and use those to calculate our data.
For the rectangular aperture, when finding the ratio of intensities for the first maxima, we got 0.0469, and then the second maxima, 0.1638, which matches our expected values based on an expectation of the sinc function itself. Plotting lines between the minimum, the first minimum, and the second minimum, and finding whether or not the maximum is symmetric, we found that it is very close to being symmetric, but small amounts of aberrations can cause it to be off. For the circular data, we used a sombrero function to compare, and the ratio of intensities for the first maxima was 0.01754, and the second maxima was 0.00415. We did not have any reference data to compare this to, but we are assuming it's right. When using the same procedure to see whether or not the maximum is in the center of the 2 minima, it is much closer than the rectangular aperture.
Hey, guys, get out of the way. What are you doing?
We're filming a video.
Duro.
You're just as dirty as milk.